Hello everyone, today we'll be diving into the 16 to 1 multiplexer. The 16 to 1 multiplexer is a more advanced version capable of selecting from 16 different inputs using just 4 selection lines. This extremely makes it useful in complex circuits where efficient data routing is needed. In this presentation, we will break down how 16 to 1 multiplexers works and its real-world application. So let's dive into the logism using the 16 to 1 multiplexers. So with how we discussed in the first 8 to 1 multiplexer, this one is a review of the 16 to 1 multiplexer. This is the output, the control inputs, the data inputs, and then the AND gate. So continuing, we connect all the wires to the inputs. So we just continue connecting our lines. Make sure that when you're connecting your lines, watch it well. We will continue connecting our lines. So once we've connected our wires, we just move to the truth table to connect the wires from the control lines to the end gates. So since we are dealing with the 6 to 1 multiplexer, we'll be having 4 control lines to the 8 data inputs. So on the truth table, we have this one, it's A, B, C, and then D. So we have all to be zeros. So we draw to the 0. So this is the 0. So that's dealing with the 16 to 1 multiplexer. You're going to have 4 control units, like I said, with the 5 cell lines with the AND gates. So once there are 0 zeros, we take it from this side. So with the outputs, we use this outputs. So then let's test and see if it's going to work. So we on this and then it's working. So we move to the next one, that's 1, and then have 0, 0, and then 0. So we test that one to turn this one on, the rest 0, and then 0, and then it's on. We then move to A2 and continue the same process from the truth table. So with that we have 0, 1, 0, 0. So 0, 1 and then 0 0. So you make sure it doesn't cross the path. Then the last one is a 0, so you map it to that one, and then we try that one too. So with that we have 0 1, and we on it, and then it's on. So you try that for the rest using the truth table. So continuing, we have 1, then another 1, 1, and then a 0. So that's done. Let's check. So it's 1 1 1, and then 0, and then this one's on, and then it's on. So we move to the A, move to the A8. So we move to the A8, having all zeros. And then a 1. And the A9 we have 1 0 0 1. So let's check for that. 1 0 0 1. Then we on this, and then it's on. So we move to the A10. Have 0, connect the line to the control, 1, and then another 0, and then another 1. Move to the next one, then we move to the next one, which is 1 1 0 1. So 1 1, and then 0 1. So here, and then the next one is 0 0 1 1. So we have 0 0 1 1. So let's test for that. Have 0 0 1 1. So let's move to the next one. That's 1 0 1 1. 1 0 1 1. So that's 1011 on it, and it's on. The last but two, it's a 0111. So from this, we are taking it from the truth table. So without the truth table, you can't connect the wires together. Then the last one, it's all ones. That's all highs. So we test for that one too. Turn it on, it's on. And when we do the A14 too, this one will be 0, and then that one turns on. To round up the 16:1 multiplexers, we are come to look at the real life applications. It plays a vital role in data signal selection, where multiple data are managed. So this all sum up to the 16:1 multiplexers. Thank you for listening. It's a good day. Have a good day. Bye.